Okay, I think we're live. So I am going to try to learn or use TensorFlow.js. This is my first time ever attempting it. I've learned a little bit about it before just from reading blogs and stuff online, but have never actually played with the code at all. So I received some instructions via email. It looks like a Mission Impossible uh, thing where it's like, here, do this and tell me what you think. So instruction number 1 is to skim this page. I'm just going to open this page up on incognito. Okay, this is the page. It says skim this page, and I will just read it and try to think out loud. Okay, core concepts. You have to bear with me while I read. WebGL. Okay. So you can train neural networks in a browser or run pre-trained models in inference mode. Oh, so I have some background on the concepts behind machine learning, but I do not actually do machine learning. That's another bit of context. I'm also going to drink my breakfast smoothie and water while I'm doing this. Okay, there's a getting started. Okay, so low-level building blocks as well as high-level Keras-inspired API for constructing neural net. Okay, so... Okay, tensor is the central unit. It's a set of numerical values shaped into an array of one or more dimensions. Okay, tensor has a shape. Okay, so it seems like a tensor is a generalized matrix or array or something. I've heard about this a long time ago. My knowledge of neural nets was from back when they didn't work. So it was from like 20 years ago or something. So, I've clearly heard about all this, revolution neural nets lately, but I have not, seen it myself. I have not played with it. Okay. So, okay, this is ES6 code. Okay. So you define a shape. Okay. It's the dimension. Here's the stuff. Okay. So you do that, you print it, great. This looks like NumPy arrays, kind of. In Python, which I don't use that much either, but I've heard of them. Low rank tensors. Okay, right. So these are low dimensional ones as convenience functions. 2D, so you pass in a list of lists or an array of arrays in JavaScript. Zeros, ones. Okay, it looks very similar to NumPy. Cool. Immutable. Cool. Variables. They're mutable. Okay, so update. Okay, cool. Store and then update values. Okay, so tensors are constants, variables are variable. While they allow you to store data, operations allow you to manipulate that data. So okay, square will square everything element-wise. Okay. Add, subtract, multiply. These are element-wise adds, I assume. Okay, so you basically can do matrix arithmetic on stuff. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. What are we doing? E.add.f. So this is 1 plus 5 is 6. 2 plus 6 is 8. Okay, cool. So this element-wise add. Pretty good page so far. Chainable API, right? So it returns the object, I assume, so you can chain them, very jQuery-like. Models and layers. Okay, good. A model is a function that given some input will produce some desired output. Okay, there's 2 ways to create models. You can use ops directly. Okay, so predict y equals, here's an equation, tidy. Okay, so this is an anonymous function that takes scalar, multiplies. Okay, so it's basically implementing this math equation. Constants. So everything should be in the TensorFlow type system. So scalars are just numbers, but you have to call it TF scalar. And then predict, when you call predict, there's this TF tidy function they have to deal with. I'm going to drink more of my smoothie. High-level API, a constructor model of the layers, which is, I guess, these neural net layers. I don't know, this is exciting watching me read the tutorial. This all makes sense. I mean, this is not really how to do things. It's more just a bunch of example code, which is good. Okay, so here's a simple RNN. Okay, so this is a convenience function for creating, I assume, a recurrent neural net with some built-in thingies. Model add, optimize, train. Okay, so we have a really big jump of abstraction between this example and this one, right? This one is, using a lot of the model, a lot of the built-in functionality, and that one is, kind of doing it from scratch. So I assume anything that you do that's non-trivial needs this. And I don't have a, one thing in this documentation would be nice is I don't know what the relationship between TensorFlow.js and TensorFlow is. I assume there's a pretty close relationship. I don't know if it's like a direct port from Python or whatever, or it's actually a different looking API for JavaScript. So it'd be nice to see if it's, how direct it is. Memory management, okay, because it uses the GPU, it's necessary to manage GPU memory and working with tensors. Dispose into tidy to purge it. So, okay, so you have to actually do manual memory manual memory management on the GPU. Cool. Tidy, another function. So it's like scoping. I see. So tidy kind of gives you a scope. It tidy up after and purges any memory tensor. This is cool. This is not produce the purge the inner return value. Very cool. So it kind of purges all of this stuff. That's cool. Prevent memory leaks, more carefully control. Should be synchronous, not return a promise. Updates the UI, makes remote requests. Okay, so this is something that people have to abide by, but, it seems hard to do unless you build a habit of it. Will not clean up variables. However, you can call this, okay. Comprehensive, machine learning crash course. Okay, so, this sounds good. Okay, what's the next instruction here? Whoa, what just happened? The next instruction is, from this Mission Impossible pack, is record yourself getting started doing this via script tags, installing it with npm and stuff. Okay, I'm just going to do the script tag because it's easiest, because I don't want to do those npm stuff. I mean, we could try it. Whatever. Okay, well, let's just see at least this works. Okay, so let's just try this. Okay, TF demo. The glory of 1080p is you could put this side by side and have the font be not tiny. Okay, so I'm just gonna paste this in. Easy peasy. Okay, so it's delivering from this CDN here. It loads from somewhere, from their CDN, and then it does something. Okay, let's just see what happens when I open it. I'm going to open this in incognito. Let me do that. Gonna drag this off. I'm trying to find my file. Just doing it offline here. What is it called? TF demo. Okay, so this is it. Beautiful. It looks great. It doesn't show anything. I think the demo should actually show something. It would be great. The code should run. Thank you. But yeah, I feel like this getting started page, this should actually just show something. Let's look at this. Oh, okay. The display console logged. Great. It's just a random number or something. Okay. It did something. Okay, dense. No, there's no import statement. Define a model for linear regression. Generate some synthetic data. Open the browser, see the output. Cool. Why is this a different number? Okay, I don't know why there's randomness here, but okay, seems to work. Do you want me to install stuff? Let's try to see how good this is. Whoa, what's going on here? Getting started, installing npm and using a build tool. Oh, we all love build tools. Let's see what happens with npm. Okay, I'm just gonna do npm test. I'm just gonna copy this in, see what happens. I don't know what yarn is. I've used npm a lot. Let's just see what happens. Whoa. I don't know if my npm is updated even. Something's happening. Okay. Something happened. Okay, got a bunch of stuff. Whee! Okay, so there's protobuf, which was some old googly thing. Protocol buffers, I assume. Wow, there's a JavaScript port of protocol buffers. Cool. There's TensorFlow stuff. Very cool. I just love how like all of this stuff is being reinvented in JavaScript now. It's like a weird throwback in time to like 10 years ago when the stuff was in, you know, Python or Java or whatever. And then like we got to do all this in JavaScript now because browsers. Okay, so let's see what happens here. Can I just run this on the back end? Let's see what happens. Ooh, I don't know what version of Node. Okay, so I'm just going to test this. Great. So test.js. I'm just going to paste. That looks ugly. This thing should not be indented. Just a stylistic thing for copy paste. This is probably silly, but whatever. This is the same code it looks like. So can I run this? Import star. Maybe I don't have the right like whatever version of Node to do these importy things. Yes, 2017 syntax. Bundler, yeah, like this is pretty complicated, I think. Like, can I do this? Yeah, this should be. Can I do this? Yeah, this installation experience or whatever is a little complicated. I'm just gonna try to use the require syntax. I don't know what this ampersand thingy is, but let's just see what happens. Turn my speakers off. Oh, okay, this works. That's cool. And I guess because Node is the V8 JavaScript engine, I would assume it's using my GPU also, even though it's not in the browser. I don't have a good mental model of whether you could use TensorFlow on your back end just as a, you know, I guess instead of using the Python or whatever version, I'm just running this in Node. I suppose I could also include this in a front end, you know, JavaScripty project. But I think this is a lot easier. I mean, this is far, far easier just to do this. You know, forget all the packaging and stuff. But yeah, I feel like this stuff needs to be a lot more fleshed out example wise. But I guess there's a lot of examples here, I assume, to do stuff. Okay, anyways, I don't want to spend too much time on this, but it seems like it works, so I can do stuff. Okay, so what's the last part? Okay, the last instruction is doing this handwriting recognizer tutorial. It says instead of copying and pasting code bit by bit, there's a GitHub with code already made. This is training stuff. Following tutorial. Okay, whatever. I'm just going to try to go for it. It's kind of fun. Okay. So training on images, recognizing handwritten digits with a convolutional neural network. Cool. In this tutorial, build a TensorFlow model. I'm just reading. Having a look at thousands of images and then evaluate the accuracy using test data the model's never seen. Okay, it looks pretty good. So it seems like someone with basic machine learning knowledge would be able to get to grok that paragraph. Prerequisites. Oh, what is training first steps? Okay. This is good. I saw this. Okay. And what is training first steps fitting a curve? Ooh. This seems important. Maybe I should read this a little bit. Train a model, discover coefficients, assuming core. Okay, so this is the second one that I should do after doing the core. So I guess the order is core concepts, which is kind of basic data types. And then this thing. Git clone this, blah, blah, blah. Do I have yarn? I don't think so. I don't actually know what yarn is, but let's see. I guess it's like a make system, maybe? All right, let's see what happens for here. Oh, there's a bunch of them. Oops. Ugh. Oh, what is yarn? Okay. Let me look up yarn. I don't know what that is. Do I npm install yarn? It's a... I'm so confused. Okay. So it's like npm, but not. I mean, this is kind of outside the scope of your tutorial, but you want everyone to use yarn. Okay. So how to install it? What is this cat picture? What is going on? Okay, there's package JSON. Is that the same as a npm package JSON? Oh, come on. Okay, I don't have homebrew, I don't think. Let me just install it. Oh, do I really have to install this through another package manager? Are they kidding me? Yeah, this is not cool. Wait, can I just npm install yarn? Okay, I'm just gonna try this. I think. Whatever. Let's see what happens. What the heck? Okay. This is ribbon. Okay. This is a little bit of a tangent, but yeah, like this installation thing, I don't know. So I just use npm to install yarn, and I didn't want to install it globally, so I just ran it here. I just ran yarn, and I don't know what's going on. I see. So it's using yarn to... Ugh. Okay, so this I assume opens the browser, cool, with the server, and it probably watches it for changes. Builds all this stuff. Okay, it seems like it's doing stuff, which is cool. Has a nice emojis into my thing. Okay, so I use npm to install yarn. Okay, that was not on the yarn page. Bad. Yeah, I've never seen yarn before, so that was not on the page of like how you can install it through npm. I just happened to Google for yarn at npm, and that's how I found this page. So it's like you have a package manager selling another package manager. Again, I don't know how much this is in scope for the TensorFlow demos, but like this might trip some people up because they're like, what the heck is yarn? And how do you install it? Okay. Oh, okay. Stuff works. Okay. Whoa. We'll just go on. I assume my computer has GPU enhanced. Okay. Cool stuff is happening. Okay, that seems to work. I don't know what's going on though. Okay. The code runs. Okay, so like getting to this point, I think people need some kind of a know-how of what the heck's going on and some kind of command line skills. Standalone. Okay, cool. Okay, XY data. Okay, so it just generated some data with noise, I assume. Okay. So this is a true coefficient, and then just generate data, and there's some noise to it. So the idea is... sorry, let me go back to this one. Keep a function, right? Our task is to learn the coefficients given the noisy data. Let's see how we do it. Ooh. Set up some variables. Okay, so we start randomly, right, with these scalars, and then we build a model. Okay, so let me open up another. Annoying thing is this font size has got to change. Annoyances of screencasting. Is this too big? Is this too small? Okay, whatever. This will have to do. What are we doing? We're looking at index.js. Right, so set up variables. Okay, we start them off at random numbers, and then we build a model, and we do a predict function that given an x, return a y, and x is a, right? So we need to know the form of the function, the polynomial. We need to know that, okay, so this returns this polynomial, and we don't know the ABCD because we assume ABCD are random, right? And then when we plot it, how do we plot it? Predict loss, async train. Wow, this is really complicated. Oh my gosh. There's a lot of stuff going on here. Okay, someone really needs to sort of know what's up in order to understand this example. Okay, so there's a UI, which is cool, which I assume is required for this thing. Okay, so the idea is once we, can I just run this again with random numbers? So this is 0.630. Right, so these are random numbers. So this is all just randomly generated each time, right? They're random cubic functions. Cool. Right, the idea here, this is the same graph, but the axes are different, right? So this is all the same graph. It's just that the axes are different here because this thing is going on. So basically, with these random coefficients, this is the curve that results, and that's obviously a wrong one. And then with some learning, it gets to hopefully the right one. And it's, you know, not really the exact coefficients, but it's somewhat close enough, I guess. Okay. Okay, predict, and then train the model. Train our model, we need to find three things. A loss function determines how well it fits. The lower, the better, okay. Optimizer, which is the algorithm for revising and to minimize output, and the training loop. Okay. Mean squared error is a standard one. Okay. Squaring the difference between actual predicted. Taking the mean. Okay. Loss labels, mean squared error. So this is just, you're just doing some math to return the error given a prediction and labels. Okay. So those are both tensors, I assume. I think that's the type of these things. And then optimizer, we use stochastic gradient descent. Gradient. All right, so this SGD seems like a library function. It's pretty common and learning rate, and yeah, okay, cool. All right, so this all seems kind of magical, but we'll take it as given. And then there's a training loop. Train GDG, okay, and it does stuff. Okay, see the results. And then what happens if we do more iterations? Okay, so, whoops. Okay, we're doing this, and can we just do more iterations? So this is still not great. How do we do iterations? This is 75. Let's do like 750, see what happens. So do we get closer? Takes longer, which is good. Takes 10 times as long, hopefully. Uh-oh. I increase it from 75 to 750. So hopefully it doesn't like barf. Oh, wow, look at that. It gets closer. That's cool. That's cool. Let's do like 1,000. Okay, so this all kind of makes sense for someone who has some introductory machine learning background, but like it is pretty much copy and paste code. Like I probably wouldn't be able to write this code from scratch because, yeah, I mean, this is kind of an idiom that's just kind of embedded in the code itself. But given the example code, I think people can adapt it reasonably well. This is an async function. Whoops. These are all asyncs. Right, so you need this await. That does this async await syntax. Right, so this async is going to be something that people have to understand as well. Async await is something that's a little more complicated to understand, and you run this thing. Whoa. Okay, so we got some yarn action here. Okay, this will take a while. I assume it linearly scales with time unless my memory barfs. I don't even know what GPU I have on here. Okay, so this is kind of fitting a curve. Cool. Okay, so then are we doing this handwriting thing demo next? Okay, so what's going on here? We'll let it finish hopefully. Yeah, this yarn page is really oh, here we go. Still not amazing. I mean, it didn't actually do that much better, even though it took longer. But I mean, like, it looks pretty good. Let's just do a really bad one. So it would be cool to be able to adjust these on the fly, right? So if there's like a slider there that just says like, ooh, slide the values. Let's just do like 10 or something really bad. Hopefully it should be pretty instant. Yeah, okay, that's really bad. Yeah, so these are all pretty bad. I don't have a good intuition for the learning rate. So that's how much it changes between every time. Just selecting. Okay, so that was this tutorial. Okay, I'm gonna go back with the next part. Okay, so now the goal is to follow this one. Training on images. Okay, so I already followed the core concepts. I followed the first steps, fitting a curve. So I have that in my cache, my brain, before I forget it all. I mean, the thing with these examples, I didn't actually have to do anything. I just kind of try to run the code and read along with it. So like, it would be really cool if you made people do something in these examples, like fill in the blank here and try to do an exercise or something, right? Something that's like, I think ideally the exercises here would be simple. Like it shouldn't require a lot. I mean, just even as simple as like adjusting the learning rate or whatever, right? Or the number of iterations and seeing what happens would be cool. Just to get people to play around with it, because I don't know what else to play around with otherwise. So like, in this example, yeah, just adjusting these. That's cool, playing around with these, making some exercises. But, this is more like a piece of clean example code. What I do like about this is that it's well commented, right? So it's kind of a step-by-step thing that's just like a commented piece of code, which is cool. I like that. And also I like how it's linear, right? So like a lot of times the code doesn't actually read up and down, but this actually reads from top to bottom, step 1, step 2, step 3, step 4. Or whatever, so forth. And, it does get a little complicated down here. Is this an async function? Yeah, this is an async function. And then, yeah, this gets a little more complicated. And it's glossed over a bit. But, and these plotting functions are asynchronous. So there's a lot of async await going on, which is, I guess, important for not having a gigantic mess of callbacks. But, yeah, I mean, it does require a little bit more expertise in JavaScript. I mean, I think this is probably not accessible to your average web developer who just kind of knows JavaScript here and there. Like they actually have to know quite a bunch about JavaScript, especially the more modern features. Okay, so what are we doing? We're doing this thing right here, TF example. Let's just run the code. Is that what my instructor said? Yeah, so this is MNIST. Okay, and do I do the yarn again? Okay, so I'm just gonna move this. This is not a great idea. I'm just gonna move this into here because I don't want to bother to install yarn. What is it? Yarn? I'm just gonna do this. Since I haven't bothered to install Yarn the right way, but whatever. It's fairly self-contained. Whoa, what just happened? I don't, oh my gosh. Do we have to compile something? What is canvas? Whoa, okay. That's not good. Core, higher level APIs, lower level algebra. Okay, so this is using a higher level API, model and layers. Should I just install Yarn globally? Let's just do that. Well, let's just do this first and see what happens. See what happens here. So MNIC data set for tutorial. Okay, so this is the handwritten digits database. So this is some data set that I guess, whoa. Okay, a bunch of stuff is happening. Okay, cool. And there's a pretty standard data set for here. I don't know what just happened here. It said success, but a bunch of errors came up. Let's just do yarn watch. I'm just following the directions here. Okay, let's see if it goes. A lot of stuff is building. Okay, cool. Loading data. Whoa, okay, stuff's happening. That's cool. Is it zoomed in? Why is the font so small? Cool. Something's happening. It runs, which is good. I don't know what's going on, but it runs. Okay. Data. Okay, so these are our handwritten digits. To pre-process, we've written data.js, which fetches random batches from a hosted version. Okay, so it just grabs our data sets for convenience. Okay, let me just look at data.js, see what's going on here. Let's kill this. Whoa, did I? Oh, ha. That's cool. It picked the random other port. That's nice. I like that. Whoa. And does this work on my default port? That was kind of cool because I had two instances running and I thought it was gonna not work because the default port was already picked. Then it picked a random other port. That's a nice touch. So that means you can run several demos at once and it doesn't interfere. So I guess these losses are getting smaller and the accuracies are getting bigger and stuff. So these visualizations are cool and how they update live. Okay, so let me web application builder. I've not heard of this one either. It looks cool. There are so many of these out there now. There's Webpack, Browserify, Parcel. Okay, I'm gonna close this. Close this. Okay, so this is some data set. Again, I'm not a machine learning person, but I assume this is a pretty legit data set. And let me look at the code. So this is MNIST. So this uses the non-low-level API. That's what the instructions say. Okay, so data, this grabs. Okay, so this just loads these images into these canvas, these image canvas 2D HTML canvas objects with buffers. Cool. It just loads a bunch of data and it grabs a bunch of batches. Cool. So it turns these pixels into Tensor 2Ds. Cool. Next test batch, slice it. So this kind of is the mechanical code behind splitting up the images into training and test sets. And these are all just buffers of numbers. Cool. What is this? Let's see what this is. I'm just curious what they're stored as. Oh, this is all of them, I think. All right. Whoa. I guess it's just the raw data of all of them. And then they're just kind of parsed apart. Anyway, this is not relevant to the demo. I'm just curious where you're getting all this data from. What is this labels? Whatever. Okay. Plane is flying overhead. Okay, I'm just trying to understand what's going on here, but okay. At a high level, the code looks pretty readable. It looks like it's good enough for people to take and play with. A bunch of numerical arrays of data. Okay, pre-process, okay. Splits the entire data set into training and tests, training model, test data. Okay, so next train batch, right? Returns a random batch of images and their labels. From the training set, returns a batch of labels from a test set. Good. Randomly shuffle data so the models aren't predictions, aren't affected. Yep, cool. That's cool. Okay, so it gives us data, which is good. Now, building the model. Sequential model, which tensors are passed from one layer to another. Okay, TF sequential. So we do this in index.js. What is UI? Let's see. Vega embed. Oh, so this uses Vega. Oh, interesting. I wonder how recent of a development this is. This is really cool. So it's actually using Vega Lite to plot this stuff, which makes a lot of sense. Very cool. So I guess these are Vega plots, which is very, very cool. Excellent. And it's dynamic too, so it moves. Okay, whatever. The UI isn't part of it, but that's nice. Okay, so what do we... these are the core concepts. All right, where's the sequential? Right, so this is our model. And we add layers. Okay, so these are layers on our neural net, I assume. So conv2D, two-dimensional convolutional layer, convolution, slide a filter window over an image. Convolution, see this article. Cool. Very cool. Nice images. Transformations. 2D convolutional layer. Okay, I'm just these look like magic to me, but they look good. We do stuff, and then shape, black and white images, size. Right, so these are all prior parameters. Okay, so we have one layer, and then we put a second layer, what's called max pooling, downsample the results, adding the minimum value. Okay. Pool size tries. Okay. Adding remaining layers. Okay. Common pattern neural networks. Let's add a second layer, another pooling layer. Doubling the iterations. I mean, these all just seem like magic to me. So as a non-machine learning person, I'm like, okay, sounds good to me. That's, it's like how you design. I mean, I guess like this is all the secret sauce, right? Like how you're designing these models and putting pieces together and figuring out what's going on. I mean, this is all opaque to me. So this looks good. Blah, 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 blah. Okay, we do all this. You train it, construct an optimizer, define a loss function. Ooh, training first steps. Oh, we did this already. Okay, so the set of documentation, reaches fixed point pretty well. I mean, there aren't that many. Okay, so then there's this to catching that gradient descent. Very cool. Oh, there's a whole machine learning tutorial thing. That's pretty cool. Oh, it's a glossary. That's really cool. I like it. That is very cool. Machine learning crash course. TensorFlow.js APIs. This is really cool. Interactive visualizations of algorithms. This is pretty cool. This is something I could totally go through sometime in my copious free time. Okay, learning rate. This is similar to this example, right? Optimize your learning rate. Okay. Defining loss. Okay, cross entropy, which is commonly used. Classification task. I'm gonna drink some more water while I read. Okay, so we compile them. So I guess this is a higher level model API. Okay, there's just a bunch of stuff here. There's a lot of stuff here. Parallelize, batch multiple inputs, single feed forward. Yeah, but there's a lot of stuff here. Whoa. There's a lot of stuff. I mean, this is all helper code, but train. Okay. Update parameter. Okay, this is getting pretty complicated for someone who doesn't know anything about this. I'm just reading. Training loop. Okay, cool. See the results. That looks cool. Oh, let me look at the low-level ones. So I'm gonna look at the MNIST core. I assume this data is the same, maybe? Yeah, it's the same a little bit. This is, whoa, what just happened? Oh, is there a model? Okay, so this is like the super low level API for defining these models. Yeah. I guess this is the super low level API convolution network. Final layer. So there's a layer, second convolutional layer, models, predict, and stuff. Whereas we're using a higher level API. Oops. Here. Even though there's still a lot of code, we're using a higher level model API to do this. Yeah, I mean, this works. I didn't really have to do anything. I don't know if I would be able to do this not following these instructions. I just basically, the nice thing about this example is it runs and I can see what's going on. But, I don't know if I can go off the rails here. This is all pretty dense stuff. I mean, I'm assuming if someone has, taken an intro machine learning course, it would make a lot of sense because these concepts seem to make sense. But this library, I don't think does much to help you if you don't. If you don't actually know anything about this. I mean, clearly there's a lot of instructional materials that makes a lot of sense. So, this is just a quick start guide, I know, but tying this into the machine learning course much more tightly would make a lot of sense to kind of tie this tightly, because just from these instructions, I'm reading and all these words make sense, but I don't have since I'm not a machine learning person, doesn't have much resonance to me. But the cool thing is the code runs, which is nice. I didn't have to install anything, which is cool. And there's code pens. Very cool. There's code pens that you can try in your browser. So I mean, this gives me confidence that real stuff can be done and it's not super slow, right? I mean, it looks like it's working in real time or something like that, which is nice Vega diagrams. But yeah, so I guess this hour or whatever, it was less about me writing any code and just me reading through the docs and giving first impressions, pretty cool. I guess this ML class looks really cool. If this was tied in with TensorFlow.js, it would be super cool. I assume this is just using the regular TensorFlow, I would assume, but like a version of this course, I haven't seen this course, but a version of this course that really ties into TensorFlow.js examples and even has like a live running code, right? Like y'all can do this in the browser, and like for every example, you just have a thing where every part of the machine learning course, you just have a thing where people can fiddle with the bits, play with the code, and like see the outputs in the visualization. This would be super, super compelling. I think this would be really cool. Yeah, so that's my first impressions of following these tutorials. I don't know, these aren't really tutorials. They're just seeing the example code, make sure it runs, which I guess the yarn thing was a little bit of a hang up, but there has to be dependency somewhere. So core concepts, we did first steps, we did this thing, and then some other stuff. But yeah, I mean, it seems pretty good in general. I mean, I feel like if I actually learned machine learning, I could apply this library to do what I need to do. Okay, so that's it for this video. Hope y'all enjoyed it.